Welcome back to video number 9 in our series on basic SQL. I mentioned earlier about the use of the asterisk when selecting the attributes that you want to display. Here are some examples of the use of the asterisk as a wildcard, meaning to retrieve all of the attributes in the tables being used. You recall that the select clause of the select statement identifies which attributes are being retrieved. We are retrieving all of them. In this first one, we see we're selecting all the attributes from the employee table where the department number dno equals 5. In this one, we're selecting all the attributes from both the employee table and the department table where the department dno is equal to the employee's d number, or vice versa. I'm not sure which attribute is in which table. And dname is equal to research. And in this last one, we're selecting all the attributes from the employee table and the department table, and you'll notice that there is no where statement, which means it's going to retrieve every possible combination of attributes from the two tables. Probably not a particularly useful query. As I mentioned in an earlier video, SQL treats a table not as a set, but rather as a multiset, meaning that duplicate tuples can appear more than once in a table and in the result of a query. An SQL table with a key is restricted from being a set, since the key value must be distinct in each tuple. If we do want to eliminate duplicate tuples from the result of an SQL query, we use the keyword distinct in the select clause, meaning that only distinct tuples should remain in the result. Here's an example of the purpose of the distinct clause. In the first query, we're selecting the salary from the employee table. It will show us all salaries in the employee table. If multiple employees earn the same salary, it will display all of those salaries. If we only want to see the range of salaries without duplicates, we can add the distinct clause to the select statement, which will eliminate the duplicates and only show us a range of salaries for our employees. SQL has incorporated some set operations from mathematical set theory, which are also part of relational algebra. These are known as set union, set difference, and set intersection, which are represented by union for set union, except for set difference, and intersect for set intersection. The relations from these set operations are sets of tuples, that is, duplicate tuples are eliminated from the result. These set operations will only apply to union-compatible relations or tables. So we must make sure that the two tables on which we apply the operation have the same attributes and the attributes appear in the same order in both tables. Let's take a look at this query here. Query 4, make a list of all project numbers for projects that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. The first select statement brings us a list of all of the managers named Smith of all of the projects. The second select statement brings us a list of all of the workers on all of the projects whose name is Smith. The union operation between the two select statements gives us the desired result of listing all of the employees named Smith who are working on all of the projects, regardless of whether they're working as a manager or as a worker. Here we see several more features of SQL. The first feature allows comparison conditions on only parts of a character string using the like comparison operator. This can be used for string pattern matching. Partial strings are specified using two reserved characters. A % replaces an arbitrary number of 0 or more characters, and the underscore symbol replaces a single character. Let's take a look at these two queries to see how this works. Retrieve all employees whose address is in Houston, Texas. In query 12, we'll select the first name and last name from the employee table where address like, quote, percent, the wildcard, Houston, comma, Texas, percent, the wildcard again, end quote. The percent sign means to ignore everything before Houston. This percent sign says ignore everything after the X, which means if you had a tuple that had a value of 100 Blue Street, Houston, Texas, 99299, it would ignore the street and it would ignore the zip and give you everybody in Houston, Texas. The second example, find all employees who were born in the 1950s. Now we select the first name and last name again from employee again, where B date, which is a date, so we can assume it's a date data type. And in MySQL and in standard SQL, a date data type is structured year, a divider like the slash, month, divider like the slash, and day with 2 digits. In this example, where B date like, quote, we are ignoring the first 2 digits. We're looking at the 5 and ignoring each digit after that, which will give us the desired result of everybody born in 1950s. By the way, this same query would work if we had the underscore 5 and then the percent. It would accomplish the same thing. Now, if the underscore or the percent is needed as a literal character in the string, the character should be preceded by an escape character, which is specified after the string using the keyword escape. For example, AB / underscore CD / percent EF quote, and you see escape quote, the backward slash quote, that is defining that backward slash as the escape character, which means that it's going to ignore that underscore as being a wildcard. It's going to ignore that percent sign as being a wildcard and give us that result. All right, this looks like as good a place as any to take a break. We haven't talked about our mystery word yet, since we've been talking about using like to query for a partial string. Why don't we use partial string as our mystery word this time? So go ahead and submit your mystery word, check your knowledge, and when you're ready, come on back and we will pick up right where we left off in video 10.